Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Security Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You define central security controls in your Google Cloud environment. For one of the folders in your organization, you set an organizational policy to deny the assignment of external IP addresses to VMs. 2 days later, you receive an alert about a new VM with an external IP address under that folder. What could have caused this alert? The options are: Option A, the VM was created with a static external IP address that was reserved in the project before the organizational policy rule was set. Option B, the organizational policy constraint wasn't properly enforced and is running in dry run mode. Option C, a project level, the organizational policy control has been overwritten with an allow value. Option D, the policy constraint on the folder level does not have any effect because of an allow value for that constraint on the organizational level.
To arrive at the correct answer, we focus on the keywords, folders, organizational policy to deny the assignment of external IP addresses to VMs, new VM with an external IP address under that folder.
The correct answer is option C, a project level, the organizational policy control has been overwritten with an allow value.
Why is this correct? C. Organizational policies in Google Cloud follow a resource hierarchy. A policy defined at a higher level, folder, can be overridden at a lower level, project, by explicitly setting a conflicting policy, allowing the assignment of the external IP address. Why are the others incorrect? A. The policy prevents the assignment of external IP addresses, regardless of when the IP was reserved. Creating a new VM and assigning an existing static IP would still be blocked by the active policy. B. Google Cloud organizational policy constraints do not feature a dry run mode. Once configured and applied to a resource, they are immediately and actively enforced across the specified scope. D. In the Google Cloud resource hierarchy, policies set at lower levels, folder, override those set at higher levels, organization. Therefore, an allow policy at the organization level would be overridden by the deny policy at the folder level.
Your organization has two VPC Service Controls service perimeters, Perimeter A and Perimeter B, in Google Cloud. You want to allow data to be copied from a cloud storage bucket in Perimeter A to another cloud storage bucket in Perimeter B. You must minimize exfiltration risk, only allow required connections, and follow the principle of least privilege. What should you do? The options are: Option A, configure a perimeter bridge between Perimeter A and Perimeter B, and specify the cloud storage buckets as the resources involved. Option B, configure a perimeter bridge between the projects hosting the cloud storage buckets in Perimeter A and Perimeter B. Option C, configure an egress rule for the cloud storage bucket in Perimeter A and a corresponding ingress rule in Perimeter B. Option D, configure a bidirectional egress/ingress rule for the cloud storage buckets in Perimeter A and Perimeter B.
To arrive at the correct answer, we focus on the keywords, two VPC Service Controls service perimeters, Perimeter A and Perimeter B, allow data to be copied from a cloud storage bucket in Perimeter A to another cloud storage bucket in Perimeter B, minimize exfiltration risk, only allow required connections, follow the principle of least privilege.
The correct answer is option C, configure an egress rule for the cloud storage bucket in Perimeter A and a corresponding ingress rule in Perimeter B.
Why is this correct? C. Ingress and egress rules provide granular, unidirectional control for data sharing between specific resources across perimeters. This perfectly meets the requirements to minimize exfiltration risk, only allow required connections, and follow the principle of least privilege. Why are the others incorrect? A. Perimeter bridges connect entire projects, not specific resources like cloud storage buckets. Additionally, bridges lack the granular directional control provided by ingress and egress rules. B. A perimeter bridge allows broad bidirectional communication between the joined projects. This violates the requirements to only allow required connections and follow the principle of least privilege. Why are the others incorrect? D. A bidirectional rule would unnecessarily allow data transfer from perimeter B to perimeter A, violating the requirement to only allow required connections and the principle of least privilege.
Your organization's financial modeling application is already deployed on Google Cloud. The application processes large amounts of sensitive customer financial data. Application code is old and poorly understood by your current software engineers. Recent threat modeling exercises have highlighted the potential risk of sophisticated side-channel attacks against the application while the application is running. You need to further harden the Google Cloud solution to mitigate the risk of these side-channel attacks, ensuring maximum protection for the confidentiality of financial data during processing, while minimizing application problems. What should you do? The options are: Option A. Enforce stricter access controls for compute engine instances by using service accounts, least privilege IAM policies, and limit network access. Option B. Implement a runtime library designed to introduce noise and timing variations into the application's execution, which will disrupt side-channel attack. Option C. Migrate the application to confidential VMs to provide hardware-level encryption of memory and protect sensitive data during processing. Option D. Utilize customer-managed encryption keys, CMEK, to ensure complete control over the encryption process.
To arrive at the correct answer, we focus on the keywords: side-channel attacks, while the application is running, confidentiality of financial data during processing, minimizing application problems.
The correct answer is option C. Migrate the application to confidential VMs to provide hardware-level encryption of memory and protect sensitive data during processing.
Why is this correct? C. Confidential VMs encrypt data in use, memory, at the hardware level, protecting against side-channel attacks during processing. This requires no application code changes, which fulfills the requirement of minimizing application problems for old, poorly understood code. Why are the others incorrect? A. While IAM and network control secure access to the instance, they do not encrypt data in use or mitigate sophisticated hardware-level side-channel attacks during processing. B. Modifying old, poorly understood application code by adding a runtime library is highly risky and violates the requirement to minimize application problems. D. Customer-managed encryption keys, CMEK, are used for encrypting data at rest, not for protecting data in use, memory, against side-channel attacks while the application is running.
You manage a mission-critical workload for your organization, which is in a highly regulated industry. The workload uses compute engine VMs to analyze and process the sensitive data after it is uploaded to cloud storage from the endpoint computers. Your compliance team has detected that this workload does not meet the data protection requirements for sensitive data. You need to meet these requirements, manage the data encryption key, DEK, outside the Google Cloud boundary, maintain full control of encryption keys through a third-party provider, encrypt the sensitive data before uploading it to cloud storage. Decrypt the sensitive data during processing in the compute engine VMs. Encrypt the sensitive data in memory while in use in the compute engine VMs. What should you do? Choose 2. The options are: Option A. Configure customer-managed encryption keys to encrypt the sensitive data before it is uploaded to cloud storage, and decrypt the sensitive data after it is downloaded into your VMs. Option B. Configure Cloud External Key Manager to encrypt the sensitive data before it is uploaded to cloud storage, and decrypt the sensitive data after it is downloaded into your VMs. Option C. Create confidential VMs to access the sensitive data. Option D. Migrate the compute engine VMs to confidential VMs to access the sensitive data. Option E. Create a VPC Service Controls service perimeter across your existing compute engine VMs and cloud storage buckets.
To arrive at the correct answer, we focus on the keywords: manage the data encryption key, DK, outside the Google Cloud boundary, maintain full control of encryption keys through a third-party provider, encrypt the sensitive data before uploading it to cloud storage, decrypt the sensitive data during processing in the compute engine VMs. Encrypt the sensitive data in memory while in use in the compute engine VMs.
The correct answers are option B. Configure Cloud External Key Manager to encrypt the sensitive data before it is uploaded to cloud storage, and decrypt the sensitive data after it is downloaded into your VMs, and option C. Create confidential VMs to access the sensitive data.
Why is this correct? B. Cloud External Key Manager, Cloud KMS, allows you to manage encryption keys outside the Google Cloud boundary through a third-party provider, fulfilling the key control requirements. C. Confidential VMs use hardware-based features to encrypt data in memory while it is being processed, fulfilling the requirement for in-use encryption. Why are the others incorrect? A. Customer-managed encryption keys, CMEK, use Google Cloud KMS, which means keys are managed inside the Google Cloud boundary, violating the external control requirement. D. Existing compute engine VMs cannot be directly migrated to confidential VMs. New confidential VMs must be created with a supported OS image. E. VPC Service Controls mitigates data exfiltration risks but does not manage encryption keys outside Google Cloud or encrypt data in memory during processing.
Your organization is building a chatbot that is powered by generative AI to deliver automated conversations with internal employees. You must ensure that no data with personally identifiable information, PII, is communicated through the chatbot. What should you do? The options are: option A, encrypt data at rest for both input and output by using Cloud KMS, and apply least privilege access to the encryption keys. Option B, discover and transform PII data in both input and output by using the Cloud Data Loss Prevention, Cloud DLP, API. Option C, prevent PII data exfiltration by using VPC to create a safe scope around your chatbot. Option D, scan both input and output by using data encryption tools from the Google Cloud Marketplace.
To arrive at the correct answer, we focus on the keywords: chatbot, generative AI, no data with personally identifiable information, PII, is communicated.
The correct answer is option B. Discover and transform PII data in both input and output by using the Cloud Data Loss Prevention, Cloud DLP, API.
Why is this correct? B. Cloud DLP API is specifically designed to inspect, classify, and de-identify sensitive information like PII in real-time text payloads, preventing it from being processed by or returned from the generative AI model. Why are the others incorrect? A. Encrypting data at rest secures stored data but does not inspect or prevent PII from being communicated in plaintext during active chatbot conversations. C. VPC Service Controls creates a secure network perimeter to prevent data exfiltration but does not inspect the payload content to filter or redact PII. D. General encryption tools secure the entire data payload but do not provide the capability to intelligently identify and selectively redact or mask specific PII elements within the text stream.
Your organization is migrating a sensitive data processing workflow from on-premises infrastructure to Google Cloud. This workflow involves the collection, storage, and analysis of customer information that includes personally identifiable information, PII. You need to design security measures to mitigate the risk of data exfiltration in this new cloud environment. What should you do? The options are: option A, encrypt all sensitive data in transit and at rest. Establish secure communication channels by using TLS and HTTPS protocols. Option B, implement a Cloud DLP solution to scan and identify sensitive information, and apply redaction or masking techniques to the PII. Integrate VPC with your network security controls to block potential data exfiltration attempts. Option C, restrict all outbound network traffic from cloud resources. Implement rigorous access controls and logging for all sensitive data and the systems that process the data. Option D. Rely on employee expertise to prevent accidental data exfiltration incidents.
To arrive at the correct answer, we focus on the keywords, personally identifiable information, PII, mitigate the risk of data exfiltration.
The correct answer is option B. Implement a cloud DLP solution to scan and identify sensitive information, and apply redaction or masking techniques to the PII. Integrate VPC with your network security controls to block potential data exfiltration attempts.
Why is this correct? B. Cloud DLP specifically identifies and protects PII through redaction or masking. VPC Service Controls, VPC establishes a security perimeter that mitigates data exfiltration risks by preventing unauthorized access and data movement across Google Cloud services. Why are the others incorrect? A. While encryption is essential for data security, it alone does not prevent data exfiltration. Encrypted data can still be exfiltrated by authorized users or compromised accounts with access to the keys. C. Restricting all outbound traffic is operationally disruptive and impractical for most workflows. Access controls and logging are detective controls rather than proactive preventive measures against exfiltration like VPC. Why are the others incorrect? D. Relying solely on employee expertise is not a scalable or reliable security measure. It lacks technical controls to prevent accidental or malicious data exfiltration, which is necessary for protecting sensitive PII.
Your organization has a centralized identity provider that is used to manage human and machine access. You want to leverage this existing identity management system to enable on-premises applications to access Google Cloud without hard-coded credentials. What should you do? The options are: Option A. Enable Secure Web Proxy. Create a proxy subnet for each region that Secure Web Proxy will be deployed. Deploy an SSL certificate to Certificate Manager. Create a secure web proxy policy and rules that allow access to Google Cloud services. Option B. Enable Workforce Identity Federation. Create a workforce identity pool and specify the on-premises identity provider as a workforce identity pool provider. Create an attribute mapping to map the on-premises identity provider token to a Google STS token. Create an IAM binding that binds the required roles to the external identity by specifying the project ID, workload identity pool, and attribute that should be matched. Option C. Enable Identity-Aware Proxy, IAP. Configure IAP by specifying the groups and service accounts that should have access to the application. Grant these identities the IAP Secured Web App User role. The remaining options are: Option D. Enable Workload Identity Federation. Create a workload identity pool and specify the on-premises identity provider as a workload identity pool provider. Create an attribute mapping to map the on-premises identity provider token to a Google STS token. Create a service account with the necessary permissions for the workload. Grant the external identity the workload identity user role on the service account.
To arrive at the correct answer, we focus on the keywords: centralized identity provider, machine access, on-premises applications, access Google Cloud without hard-coded credentials.
Review the options on screen. The correct answer is option D. Enable Workload Identity Federation. Create a workload identity pool and specify the on-premises identity provider as a workload identity pool provider. Create an attribute mapping to map the on-premises identity provider token to a Google STS token. Create a service account with the necessary permissions for the workload. Grant the external identity the workload identity user role on the service account.
Why is this correct? D. Workload Identity Federation allows external workloads, like on-premises applications, to authenticate to Google Cloud APIs without hard-coded credentials by federating their existing identities and impersonating a service account. Why are the others incorrect? A. Secure Web Proxy is used to secure and route egress web traffic, not to authenticate external applications to Google Cloud APIs. B. Workforce Identity Federation is designed for human users to access Google Cloud resources, whereas Workload Identity Federation is required for machine access like on-premises applications. C. Identity-Aware Proxy, IAP, secures access to web applications and VMs running on Google Cloud, rather than providing authentication for external workloads accessing Google Cloud services.
Your organization has recently migrated sensitive customer data to cloud storage buckets. For compliance reasons, you must ensure that all vendor data access and administrative access by Google personnel is logged. What should you do? The options are: Option A, configure data access audit logs for cloud storage on the project hosting the cloud storage buckets. Option B, enable access transparency for the organization. Option C, configure data access audit logs for cloud storage at the organization level. Option D, enable access transparency for the project hosting the cloud storage buckets.
To arrive at the correct answer, we focus on the keywords: organization, vendor data access, administrative access by Google personnel is logged.
The correct answer is option B, enable access transparency for the organization.
Why is this correct? B. Access transparency provides logs of actions taken by Google personnel and vendors. It must be enabled at the organization level to capture this administrative access, fulfilling the compliance requirement. Why are the others incorrect? A. Data access audit logs track data operations by members of your own Google Cloud organization, not actions performed by Google personnel. C. Data access audit logs do not capture Google personnel access. They are used to track data operations by your own authenticated IAM identities. D. While access transparency is the correct service to use, it must be enabled at the organization level, not at the individual project level.
Your organization is implementing a zero-trust security model and using Chrome Enterprise Premium. The company is interested in governing access to sensitive data stored in cloud storage. You need to configure access controls that ensure only authorized users on managed devices can access this data, regardless of their network location. Access should be restricted based on the device's security posture. This requires up-to-date operating system patches and antivirus software. What should you do? The options are: Option A, grant access to specific users to the VPC Service Controls to create a perimeter to access the cloud storage buckets. Configure Identity-Aware Proxy, IAP, to authenticate users before they can access the data. Option B, configure IAM conditions based on IP address ranges. Require users to connect through a VPN. Implement endpoint verification software on user devices to check for basic compliance. Option C, create an access level in Access Context Manager that requires a device policy. Create a context-aware access policy using this access level. Apply the policy to the VPC Service Controls perimeter that includes the cloud storage buckets. Option D, use cloud firewall rules to restrict access to the cloud storage buckets based on the source IP addresses. Require users to authenticate with a multi-factor authentication method.
To arrive at the correct answer, we focus on the keywords: Zero Trust Security Model, Chrome Enterprise Premium, sensitive data stored in cloud storage, authorized users on managed devices, regardless of their network location, device's security posture.
The correct answer is option C, create an access level in Access Context Manager that requires a device policy. Create a context-aware access policy using this access level. Apply the policy to the VPC Service Controls perimeter that includes the cloud storage buckets.
Why is this correct? C. Access Context Manager creates access levels evaluating device posture, managed, patched, AV, via Chrome Enterprise Premium. Applying this to a VPC Service Controls perimeter secures cloud storage data regardless of network location, matching the zero trust requirements. Why are the others incorrect? A. Identity-Aware Proxy, IAP, is used to control access to web applications and compute instances, not directly to cloud storage data based on device posture. B. Relying on IP address ranges and a VPN directly contradicts the requirement to allow access regardless of their network location under a zero-trust model. D. Cloud firewall rules apply to VPC networks and VMs, not to cloud storage. Furthermore, restricting by source IP violates the regardless of their network location requirement.
Your organization is storing regulated data in cloud storage. Data in cloud storage buckets is encrypted by Google-managed encryption keys. To meet compliance requirements, you need to update the existing data to use customer-managed encryption keys instead. What should you do? The options are: Option A, create a new key ring and key in the Cloud Key Management service. In each cloud storage bucket configuration, change the encryption type to customer-managed encryption key. Option B, identify which projects contain cloud storage buckets with regulated data. Apply the Restrict Non-KMS Services Organization Policy constraint to the identified projects or parent folder. Option C, create a new key ring and key in the Cloud Key Management service. Identify which projects contain cloud storage buckets with regulated data. Perform a write action on all existing objects in the buckets. Option D, create a customer-managed encryption key. Change the encryption type in each cloud storage bucket configuration to the newly created key. Perform a write action on all existing objects in the buckets.
To arrive at the correct answer, we focus on the keywords: storing regulated data in cloud storage, encrypted by Google-managed encryption keys, update the existing data to use customer-managed encryption keys instead.
The correct answer is option D, create a customer-managed encryption key. Change the encryption type in each cloud storage bucket configuration to the newly created key. Perform a write action on all existing objects in the buckets.
Why is this correct? D. Changing a bucket's default encryption key only applies to new objects. To encrypt existing objects with the new CMEK, you must update the bucket's default key and then perform a rewrite operation on all existing objects. Why are the others incorrect? A. Updating the bucket's default encryption configuration only affects newly created objects, it does not retroactively re-encrypt existing data. B. The Restrict Non-KMS Services Policy constraint enforces CMEK usage for new resources but does not automatically encrypt existing objects with CMEK. C. Although rewriting objects applies the current encryption, this option fails to set the bucket's default encryption to the newly created CMEK, meaning objects might not be encrypted correctly upon rewrite.
There is a vendor who needs access to your company's Google Cloud environment. The vendor uses a third-party identity provider, IDP. You need to integrate this IDP with your company's Google Cloud environment to enable single sign-on, SSO, for the vendor's users in the most secure way. You don't want to manage any of the vendor users' lifecycle management. What should you do? The options are: Option A, use Google Cloud Directory Sync to synchronize user accounts from the IDP to Google Workspace, and then configure SSO between Google Workspace and Google Cloud. Option B, develop a custom application that queries the IDP for user authentication and then programmatically creates Google Cloud user accounts. Option C, connect the vendor's IDP with Google Cloud using Workforce Identify Federation. Option D, create Google Cloud accounts for each user and synchronize their passwords with the third-party IDP.
To arrive at the correct answer, we focus on the keywords: vendor who needs access to your company's Google Cloud environment, third-party identity provider, IDP, integrate this IDP with your company's Google Cloud environment, enable single sign-on, SSO, don't want to manage any of the vendor user's lifecycle management.
The correct answer is option C, connect the vendor's IDP with Google Cloud using Workforce Identify Federation.
Why is this correct? C. Workforce Identity Federation allows you to grant external identities access to Google Cloud resources directly via their existing IDP without creating or synchronizing user accounts, perfectly satisfying the requirement to avoid managing vendor-user lifecycles. Why are the others incorrect? A. Using Google Cloud Directory Sync involves creating and synchronizing user identities into Google Workspace or Cloud Identity, which directly violates the requirement to not manage vendor users' lifecycle management. B. Developing a custom application to programmatically create Google Cloud user accounts means you are still provisioning and managing user identities, violating the strict requirement to avoid lifecycle management. D. Creating individual Google Cloud accounts for each user involves provisioning and managing those identities, which contradicts the core requirement that you do not want to manage user lifecycles.
Your organization is planning to deploy a large number of Google Kubernetes Engine (GKE) clusters to run business applications in different folders and projects. You must ensure that all GKE nodes always run the latest release to minimize vulnerability risk and administrative effort. What should you do? The options are: Option A, after creating clusters, use the Google Cloud Console Cloud Container Node Pools describe node_pool_name cluster equals cluster_name command. Examine the upgrade settings and update info output. Option B, create a custom organization policy constraint resource.management.auto-upgrade equals true with an action type of allow at the organization level before deployment. Option C, create a new node pool with the newer version for each cluster. Migrate the workload. Eliminate the outdated node pool. Option D, manually run the Google Cloud Console Cloud Container Clusters upgrade cluster_name node pool equals node_pool_name cluster version command on newly created clusters regularly.
To arrive at the correct answer, we focus on the keywords: deploy a large number of Google Kubernetes Engine (GKE) clusters, different folders and projects, always run the latest release, minimize vulnerability risk and administrative effort.
The correct answer is option B, create a custom organization policy constraint resource.management.auto-upgrade equals true with an action type of allow at the organization level before deployment.
Why is this correct? B. Creating an organization policy constraint at the organization level centrally enforces that all future GKE node pools across all folders and projects have auto-upgrades enabled, minimizing administrative effort. Why are the others incorrect? A. Describing cluster configurations after creation is a reactive operational task and does not enforce a policy across the organization to automatically run the latest releases. C. Creating new node pools and migrating workloads manually is extremely labor-intensive, completely failing the requirement to minimize administrative effort across a large number of clusters. D. Manually running upgrade commands on newly created clusters regularly is inefficient, does not scale across multiple projects, and requires significant ongoing administrative effort.
Your company is in a regulated industry that requires low overhead encryption using private connectivity from on-premises data centers to Google Cloud. You need to establish connectivity and ensure high availability across multiple regions. What should you do? The options are: Option A, set up 2 pairs of HA-VPNs using IPsec from the data centers in multiple regions. Option B, set up pairs of cloud interconnect connections to your data centers in multiple regions, and employ MAC-SEC encryption. Option C, set up L2TP encryption over pairs of dedicated cloud interconnect connections from the data centers in multiple regions. Option D, set up IPsec encryption over partner interconnect connections from your data centers in multiple regions.
To arrive at the correct answer, we focus on the keywords: low overhead encryption, private connectivity, high availability across multiple regions.
The correct answer is option B, set up pairs of cloud interconnect connections to your data centers in multiple regions, and employ MAC-SEC encryption.
Why is this correct? B. Cloud Interconnect provides the required private connectivity. Employing MASEC, Media Access Control Security, provides low-overhead, line-rate hardware encryption natively supported on Cloud Interconnect, fulfilling the strict regulatory requirement for low overhead. Why are the others incorrect? A. A VPN traverses the public internet by default, which does not satisfy the requirement for private connectivity. Additionally, IPsec introduces higher processing overhead than MASec. C. Google Cloud does not natively support or recommend L2TP encryption over Cloud Interconnect for this use case. MASec is the standard supported mechanism for low overhead encryption. Why are the others incorrect? D. While Partner Interconnect provides private connectivity, implementing IPsec encryption over it introduces significant processing overhead, failing the specific requirement for low overhead encryption.
You manage the security logs within your cloud environment. You have configured a continuous export of security logs to cloud storage buckets for long-term retention. You need to provide auditors the ability to analyze the logs that were exported to cloud storage. Your solution must be cost-effective and quickly implemented. What should you do? The options are: Option A, use a VM instance to download the data from cloud storage. Provide the auditors access to the VM and allow them to install their preferred analytics toolset. Option B, use the data in the cloud storage bucket as an external table in BigQuery. Provide the auditors access to the BigQuery dataset. Option C, use Dataflow to import the data from cloud storage into Elasticsearch. Provide the auditors with access to Elasticsearch. Option D, use a Cloud Run job to import the log data from cloud storage to cloud logging. Provide the auditors access through Log Analytics.
To arrive at the correct answer, we focus on the keywords, analyze the logs, exported to cloud storage, cost-effective, and quickly implemented.
The correct answer is option B, use the data in the cloud storage bucket as an external table in BigQuery. Provide the auditors access to the BigQuery dataset.
Why is this correct? B. BigQuery can query data directly from cloud storage using external tables. This eliminates data movement and duplication, providing a highly cost-effective and quickly implemented solution for log analysis. Why are the others incorrect? A. Managing a VM instance and manually downloading data is not quickly implemented and introduces unnecessary compute and storage costs. C. Using Dataflow to move data to Elasticsearch requires significant setup time, data duplication, and ongoing management costs, making it neither quick nor cost-effective. D. Importing logs back into cloud logging via Cloud Run introduces unnecessary complexity, data duplication, and increased costs compared to analyzing them in place.
A customer needs to prevent attackers from hijacking their domain/IP and redirecting users to a malicious site through a man-in-the-middle attack. Which solution should this customer use? The options are: Option A, VPC flow logs. Option B, Cloud Armor. Option C, DNS security extensions. Option D, Cloud Identity Aware Proxy.
To arrive at the correct answer, we focus on the keywords, prevent attackers from hijacking their domain/IP, redirecting users to a malicious site, man-in-the-middle attack.
The correct answer is option C, DNS security extensions.
Why is this correct? C. DNS security extensions, DNSSEC, protects against DNS spoofing and hijacking by cryptographically signing DNS records, ensuring users are not redirected to malicious sites via man-in-the-middle attacks. Why are the others incorrect? A. VPC flow logs capture network traffic information within a VPC but do not actively prevent DNS hijacking or man-in-the-middle attacks. B. Cloud Armor provides DDoS protection and WAF capabilities but is not designed to secure DNS resolution or prevent domain hijacking. D. Cloud Identity Aware Proxy controls access to applications based on identity and context, but it does not protect against DNS hijacking or redirection.